Authored by veteran chemistry teacher Abdul Shakur, these two textbooks provide all the essentials that would not only enable students to master grade 11 chemistry, but to excel at the next higher level in this subject. What make these texts unique are their creativity and profundity with which concepts are explained for clarity and mastery. The following is one of a set of 44 different tutorials created by the author, using materials primarily from the text Chemistry 11 in Focus. I hope you enjoyed this video. If you liked it, please give it a thumbs up and don't forget to subscribe. We will see you in the next video and thank you for watching.
Today we'll be teaching you how to write the formulas and names of acids. This is one of the areas in grade 11 chemistry that students experience some degree of difficulty with. So as such, I've taken my time to break it down in ways to facilitate your understanding of how to do this. We'll be talking about writing the names and formulas for binary acids, then the same for ternary acids or oxyacids, and then for salts, and then we provide a flowchart for naming compounds. We first of all proceed by writing the formulas and names of binary acids. So what's a binary acid? A binary acid is formed when the hydride of one of the following nonmetals, these fluorine, chlorine, bromine, iodine, and sulfur, is dissolved in water. For example, when the compound hydrogen chloride is dissolved in water, it is changed to the acid hydrochloric acid or aqueous hydrogen chloride. There are two ways of naming acids. One is called the classical way and the other one is the UPAC system. Like we said, when one of these hydrides dissolves in water, the corresponding binary acid is formed. For example, the hydride of fluorine is called hydrogen fluoride, for chlorine, hydrogen chloride, for bromine, hydrogen bromide, iodine, hydrogen iodide, and H2, should be a 2 here, that's called hydrogen sulfide. Now these all by themselves are neutral things without the presence of water. But when you dissolve these in water, they now become acidic. And look what is happening here. I deliberately put G to indicate their state, their gaseous things. When they dissolve in water, I explained to you already how hydrochloric acid is formed. Water encourages the ionization of this molecule, where the chlorine takes away the entire pair of electrons from the hydrogen, and the hydrogen is free. So this is what is happening. Okay, these are called the binary acids right now. Okay, let's see how you name them in two different ways. UPAC system, that is International Union of Pure and Applied Chemistry. We discussed that already when they name of compounds. You're going to say aqueous hydrogen, whatever the thing is. So if you see this, that gets dissolved in water, and you see that aqueous sign here, you know now all these are acids, okay? So be mindful of that. When you see the aqueous sign with these non-metals here, and they have a hydrogen here, note that an acid is formed, all right? So you were just going to say aqueous hydrogen fluoride. We know that was hydrogen fluoride already. We know that it was hydrogen chloride and so on. All you do is to put aqueous in front of it, and one will know therefore that, look, this thing is now dissolved in water and it forms an acid that we call aqueous hydrogen chloride. Now let's look at the classical system of naming that. This is what you're going to do now. The word hydro comes in. Let's take this one here for example. This is aqueous hydrogen fluoride. So in the classical way, you put hydro. Hydro comes now. You don't say hydrogen anymore. And the fluorine is cut short to say fluor. And you end it with ic. So fluorine becomes fluoric. Chlorine becomes chloric. Bromine becomes bromic. Iodine becomes iodic. Sulfide becomes sulfuric in this case. So you put hydro, fluoric, and then you put acid in the end. See this one here? The UPAC system, there is no acid mentioned there. Only in this case, the acid is mentioned, but you modify the name of the nonmetal there and you add ic to it. So this was hydrogen fluoride. In the classical way, you're going to put hydro and then you become fluor, and instead of ide, you put ic. This is going to become hydrochloric, and then you add acid to that. Okay, I hope that was helpful. So you have a prefix here called hydro. In every case, it's hydro. And then you cut short that fluoric. Fluorine becomes ic and acid. So the root is fluor, the suffix is ic, and then you end up with the acid. And you can see that for everyone there. Hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrosulfuric acid. So note that then, okay? Next. I've explained all of that here to you, excuse me. That's what I just did there, all right? If you want to read that back, consolidate your understanding, no problem. Writing formulas and names of ternary or oxyacids. Ternary acids, also called oxyacids, contain oxyanions and hydrogen. The oxyanion and the acid that it forms with hydrogen depends on the nature of the nonmetal and the number of oxygen atoms present in the oxyanion. For example, let us say you have this oxyanion. The nitrogen is here, so we know it will have N, it will start with nitrate. And because you have 3 oxygen to that radical there, it is 8 nitrate. You see? When you have 3 oxygen, it becomes 8. So it becomes nitrate. The acid that is formed from it now, if a hydrogen is present with it, it's called nitric acid. So we watch this table here and show you how these various acids are written and how they are named. Lots of information is condensed here. This is what I did. You have columns and you have rows, okay? These rows here correspond to the nonmetal that is found in the acid. So in the second row, you're having those that are associated with chlorine, bromine, iodine, nitrogen, carbon. Okay, this is what I am saying here. Okay, this is a nonmetal, no problem. Listen attentively, have some patience, and everything will make sense to you. I'm giving you here the number of in the oxyacid. Anything with 3 oxygen atoms, I'm going to refer that as my standard, okay? And we're going to say that they end in ic. For example, of course, they will all have hydrogen, you have a nonmetal, and you have the number of oxygen connected to it. See, look. You always will have hydrogen in the acid, right? You must. And then because the H that causes acidity, of course, then here's a nonmetal there, okay? This case is chlorine. And now you have oxygen, okay? How many oxygen do you have? I have 3 oxygen. So I say when you have 3 oxygen, I call it a standard, so you're going to say ic. So how do you say? You are going to say, you're going to call that chloric acid. You get that from chlorine, and you say ic. Note how we are not using hydro in this case. Hydro is only used when you have binary acids, not when you have oxyacids. Don't mention hydro at all here, okay? So it becomes chloric acid. If it is HClO4, you see it's more, it's beyond. So I'm saying to you, this is standard, is ic. When you have one more, it's per-ic. So it's the same thing here, but they distinguish this acid here from that acid there, because this one has 4 and that one only has 3 there, right? You say poor chloric acid. It is still chloric acid, but it has one more oxygen there, and they call that poor chloric acid. Now, watch this. Anything has 1 less than 3, that means you're having 2. So I'm going to say us. Instead of ic, the acid becomes us. Chloric now becomes chloros. All right, note that. So if you know your standard, you work forward and you work backward, okay? So chloros has 2. So it becomes chloros acid. If it has even 1 less than that, So it has 2 less oxygen than the standard. This has 1 less oxygen than the standard. That has 2 less oxygen. It is still chlorous acid, but 1 oxygen less than what this one was. We say is beneath that is hypo. So one more time. Any acid that has 3 oxygen with it, I'm saying to you, there's some exception. You point to those exceptions to like sulfuric acid and phosphoric acid. Okay, there are 4. So any of these here, right, with hydrogen and iodine and bromine and fluorine and that has 3 oxygen, we say is ic. So just to call the name of the nonmetal. If it's bromine, it becomes bromic. If it is chlorine, it becomes chloric. If it is nitrogen, it becomes nitric. If it is iodine, it becomes iodic. Okay, so that's with 3. If it has 1 more, it becomes por that. So let's look at bromine. Why don't we look at bromine? So, see this? It becomes bromic acid, right? 1 more becomes bromic acid. Now, what's 1 less? Bromous acid. 1 even less than that, hypo, beneath this, it becomes hypobromous acid. And you can make the same claim for all of these: iodine, iodic, poriodic, iodous, hypoiodous. See? Nitric, there's not, I haven't seen anything like that. Nitric acid, nitrous acid, I don't think, where these X's are, I'm telling you, they don't exist, okay? Carbonic acid, 3. Carbonous acid. There's some exceptions. In case of sulfur here, it will have 4 as a standard, and then 1 more will become persulfuric acid. This is sulfurous acid, and hyposulfurous acid won't be. Now look at phosphoric acid, same thing we said. It has 4, that makes it phosphoric. I haven't seen that. 1 less, phosphorus acid, hypophosphorus acid. Okay? Now we're going to look at something else that's important. This acid here has a radical, COO3. It is called chlorate. See? The chlorate ion. So if something is chloric, it becomes chlorate. If something is perchloric, it becomes perchlorate. And this is how we're going to form salts. If I put a sodium here, sodium atom here, it becomes sodium perchlorate. You see that? Alright? If I put a potassium here, what does it become? Okay, potassium chlorate, right? If I put a lithium here, what does it become? You tell me. Lithium chloride, okay? And if I put the same lithium here, what does it become? Lithium hypochlorite. So from the acid, you can know what the radicals are, and based on the name of the radical, you'll know how to write the salts that are emanating from these acids here, okay? Let's do another one. Let's do the rest. Bromine. Bromic acid, when it ionizes, just like this here, okay? Instead of chlorine, I'm going to have bromine there. You're going to have a bromate ion, right? And the bromate ion because of 1 more oxygen. Bromite ion because it's less. Hypobromite ion. And any metal ion that's there, you can form the corresponding salt from that, and you will know how to name that. Iodine, iodic acid, gives me the iodate radical. Poriodic acid gives me poriodate radical. Iodous acid gives me iodite. Sometimes students mix up chloride, ide with ite. When you see ite, know there's oxygen there. Ide, sodium chloride means these are binary ionic compounds, right? If I put a sodium here, look, that what does that become? Sodium iodide, right? It is different from sodium iodide, I, when you put an I alone there. So this is the point I'm making there, okay? Nitric acid, you get a nitrate radical. Carbonic acid, you get carbonate radical, and so on. So that is how you name and write the formulas of oxy acids. One more time, quick review. What were you saying? The oxy acid is named by looking for 3 things. 1, if it has hydrogen inside with a radical, right? You're going to see a nonmetal with oxygen inside. They're called oxy acids. The binary acids, do not have oxygen inside. To guide us to naming these, I'm saying, I'm going to use my own strategy here. Whenever you see 3 oxygen in the compound, it will end in ic. If it has 4, you put por in front of it. In this case, this is chloric acid. It becomes porchloric acid. 1 less becomes us. So it becomes chlorous acid, hypochlorous acid. And with these come their corresponding radicals. You see ClO here becomes a chlorate radical, okay? So ClO4 becomes a porchloric radical. ClO2 becomes, from chlorous, it becomes chlorite, all right? And for hypochlorous, it becomes hypochlorite, and all the rest follow the same pattern there. So that's how you name, or write, if you want to write, oxyacids, the formula and the names for these. All right. Now we're going to look at the classical, compare the classical and the UPAC system now. That was the classical system we named just now. Okay, same thing we did here, classical system. There's going to be bromic acid, porbromic acid, bromous acid, hypobromous acid. That is why now I was telling you about the radicals that are formed. From the ic, from the bromic, we get a bromate radical, right? See? We get a bromate radicals. So in the UPAC system of naming that, all you say hydrogen bromate. You see, you're saying that this bromate here has a hydrogen in it, aqueous, but you have to put the word aqueous. Aqueous hydrogen bromate. See, I'm saying bromous becomes bromite. Brom, see, ic becomes 8 again. See? Por ic, I'm going to put por here. So bromic becomes bromate, aqueous hydrogen bromate, aqueous hydrogen por bromate, and this us becomes ite now, bromite, aqueous hydrogen bromide, aqueous hydrogen hypobromite. I hope that was helpful for you there. So go back again and watch this again and digest what I've been telling there. All right, let's go now a little bit now. See what we have here. There's some ones that are unusual. You're going to learn this by yourself. This has become hydrocyanic acid here, cyanide radical, acetic acid, oxalic acid, dichromate, thiocyanate radical, thiosulfate. There's some unusual ones, and it's not a usual way of writing it, so I depend on you to learn these in discrete ways, okay? Oh, another thing is sometimes salts, we have alluded to this already, they have water crystallization inside, right? All you do is to name this as it is. Oh, name this part first, in a sulfate, and that is a copper 2. So you're going to say copper 2 sulfate pentahydrate. Writing formulas contain polyatomic ions. We know that copper is 2 plus, and each nitrate radical is 1 negative, right? So you'll need 2 nitrates for this to become electrically neutral, right? To balance off those 2. We've alluded to this already. We've taught you that already. So that's how you're going to do that, okay? All right. Or you can do the crisscross method. That is a 1. It comes here, okay? And that goes outside of the bracket. Remember, we have radicals. They have more than 1. You have to put parentheses there, and you put the 2. So that's easy to know, right? I'm always emphasizing the point that these things guy here, they move as a block. So you don't break them up when you're doing chemical equations and stuff like that. And here's some practice problem for you, all right? All these are from the solution manual, the answers too. And this is a big flow chart here that I made for you guys, all right? This will take some time. So let us see how you can discriminate between different types of compounds. So it's a big question. If you're given a compound, it's a big question you ask. Is it a binary compound or a polyatomic compound, okay? If it is a binary compound, you'll only have 2 elements present. If it is a polyatomic compound, you'll have more than 2 elements present. So watch your compound there and decide first of all. If you decide it's a binary compound, then you decide if it is binary molecular or binary ionic. If it is Having two nonmetals only, it becomes a binary molecular compound, and you do it using the prefixes and stuff like that. This is carbon monoxide, nitrogen dioxide, phosphorus trichloride, dinitrogen tetroxide. Note they all end in "ide." Okay? All binary compounds will end in "ide." That is for binary molecular compound. If it is two elements, but is not binary molecular, it will have a metal and a non-metal. Okay? They can use, this is a very nice flow chart for you to watch. Okay? Okay. There are two types of metal. You can have metal ions with standard valence and those with multiple valence. Okay? So if it is standard valence, you name it as it is. For example, this is magnesium. It belongs to group 2A. You just name it as magnesium chloride. Zinc, yes, standard, zinc oxide. But if it has a multiple valence, you can do the classical method of saying it's "ic" or "us." For example, look, this becomes ferrous chloride because a lower valency, 2 plus ferrous chloride, or you can say ferric chloride, or you can do a UPAC system where you use Roman numerals, right, in bracket. This becomes iron 2 chloride, this one becomes iron 3 chloride here. That is finishing off with binary compounds. That's a quick review. Polyatomic compounds now. You'll have to decide if it's molecular or ionic. If they're molecular, they do not have any metal inside. Let's say you see something like this. Only when you dissolve these in water, they form the corresponding acid. But how do you name this? You will have to name it as hydrogen hypofluorite. FO3 is fluorate. FO2 is fluorite. One less becomes hypofluorite. If you see this, how do you name that? Hydrogen, what? It's not chlorate. It's less than that, is chloride. See the ite when you have two oxygen? What is this? Hydrogen, oh, perfect, bromate. Hydrogen, 4, hyperiode, and the corresponding acid. If I put this in water now, it becomes acid, right? How do you call that? You're going to say hypofluorous acid. This is a classical method, right? Hypofluorous acid. This is what? It's not hypo, it's 2. Trigorous acid, bromic acid, periodic acid. How would you name this now in the other system? You have to say aqueous hydrogen hypofluorite. This would be what? Aqueous hydrogen chloride. This will be aqueous hydrogen bromate, if you want to name that the other way. When you have these with metal ion, now you get it as salt, right? Okay, watch this now. If you say KIO, go to the standard. IO3 is 8, IO2 is 8, IO must be hypoite. So it becomes potassium hypoiodite, okay? What is this? Not BrO3, which is 8. It's less, it's 8, it's bromide, so it becomes sodium bromide. Now you have 8. Lithium, nitrogen there, lithium nitrate. Alright? Then you have now, this is 4. This is por, right? Okay, por, and you see calcium is regular, standard, so it becomes calcium perchlorate. If you have metal ions now, naming those with multiple valence, you'll have to do it either the two-way, right? You're going to say "ic" or "us," or you can do it in this way, right? "Ic" or "us." It will be plumbous iodide, 2 plus, and if you have now, or you can say lead 2 iodide. I hope that was useful there. Why don't we therefore put away that thing there and quickly do these ones. What is the big question? Polyatomic or binary? Binary. See that? If it's binary, what do you say? Molecular or ionic? Ionic. Why? Metal and this. So it becomes, if it's a metal and a non-metal, what is it? Regular, standard, or multivalent? No, standard, magnesium chloride. What is this? Binary or polyatomic? Only 2 elements too. And they're both non-metal, so it's molecular, phosphorus trichloride. What about this guy here? Binary or polyatomic? Polyatomic. So now what is it? Is iron something, right? And now you have NO3, that's a nitrate, okay? Two ways of doing this. You can call it ferric nitrate because you see it's a 3 there, and this is 1 negative here. This is 1 negative, nitrate. Iron is ferric nitrate, or you have to say iron 3 nitrate. This one, binary or poly? Binary. Molecular or ionic? Ionic. Standard or multiple valence? Standard, zinc oxide. This one, polyatomic or binary? Binary. Molecular or ionic? Ionic because of the metal. Now this one is that standard or multiple? Multiple, that is not from group 1, 2, or 3, right? Bromine has a 1 negative here. That's how you figure out what it's going to be. Now you have 2 bromine. You say that, what is it? Lead 2 bromide or plumbous bromide, okay? Lower valence. This is what? Poly or binary? Binary, yes. Ionic or molecular? Molecular both. But look what? You have hydrogen there and aqueous. It's an acid. It's a binary acid. Becomes hydro. Now you see binary has hydrosulfuric acid. If it was Cl there, it'd be hydrochloric. Alright? This one. This one. What is it? Polyatomic. All non-metals. And then you have this one here. Hydrogen there with aqueous. It's an acid. 2 ways. Call it chloric acid. Chloric because of 3 standard. Or you say aqueous hydrogen chlorate. The other way. What is this? Polyatomic. All not non-metal is a metal here. That means a salt. Okay? Then look at the radical here. IO. It's not IO3, it's iodite. It's become potassium iodite. What is this? Polyatomic. Is a hydrogen there? It's aqueous. Must be an acid. What is a non-metal? It's iodine with 4. So it becomes what? Periodic acid. And if you want to do it the other way, aqueous hydrogen periodate. This one here, again, polyatomic, is a radical here, and a metal here must be a salt. What is this guy here? As bromine and 2 oxygen less than 8. So you have 3 is 8, 2 is 8, 1 is hypoite, right? So it becomes what? And this is 1 negative here, so iron must be 2, because you have 2 of these radicals. So what is it? Ferrous hypobromite. Or, what's the other one? Iron 2 hypobromite. And of course, this one will be perfluoric acid, or aqueous hydrogen perfluorate. And I have for you here, some sweet, nice true and false matching questions here, all right? Oh, what happened here? True and false. Nice multiple. Hey, what's wrong? I did all these things so nice for you. Multiple choice questions there. You can find it in the solution manual. All right? They're nicely laid out there, and the answers are given too. All right. Wow, we're coming to the end of our things. Next thing, chapter, I think we're starting gases. I'll talk to you later on.